After we substitute the 0 in the x, it gave us 0 over 0. So we have to do something.
What we did was that we made the conjugate multiplying what's on the top but with different sign on top and in the bottom. So what this gives us is
By canceling the x's, we have a 1 on the top, we cancel the x besides the 3, and we have this equation. So now,
Then in this equation we substitute the 0 and the x, so it gives us this. Then we add these two square roots and it gave us this.
by multiplying these, we have this equation, and by simplifying, which is multiplying by the same conjugate, top, bottom, you give us our final answer, which is limit x tends to 0, square root of 2 over 12.
in this problem we use the procedure of by definition, which is this formula f of the x plus h minus f of the x over h. So in this procedure, for every x we had, we first substituted x plus h. So here are the first x, then the second, the third, with x plus h everyone. And then we followed this rule, which is minus f of the x. So we only rewrote this, but with different signs, and we left the h.
In here, we use the formula of binomial cubed, which gave us this equation. Then we use the binomial squared, which gave us this equation. And then here we just multiply the 5 times the x times the h, and we put the rest of the equation just as it is on top.
Then in this equation we multiply the 2 by its parentheses, the same as with the 6. Then it gave us this, so we cancel opposite like terms, as in here the 2x cubed with the negative 2x cubed, the negative 6x squared with its opposite, as the same as with 5x and with the 7.
The next step that we did was we took out the h as a common term, and after we canceled both h's, and we ended up with this. After, the next step and the last step is to substitute all the h's for a 0, and the final answer is f prime of x equals 6x squared minus 12x plus 5. This is the derivative of this function.